I've been sitting in the basement reading room at Patty Library in State College for 4 hours, going through old housing research binders, and I need to tell you what I found. What I found in a Pennsylvania Housing Research Center report from 2013 changes everything you think you know about keeping a house cool. The number is 134 watts per square meter. Hold that number for a second. Do not explain it away yet. Do not shrink it into a utility bill. Just keep it in your head. 134. Because that number sat on the page like evidence. Cold, simple, measurable. And the longer I stared at it, the stranger this whole story became. I was surrounded by ordinary things. Bound reports, dust, fluorescent light, a steel cart with faded labels. Nothing about the room suggested a secret worth protecting. But there it was anyway. The next folder made it worse. Oak Ridge National Laboratory. Attic models, climate zones, old houses, new houses, leaky ducts, tight ducts, different roof assemblies, different emittance values, different outcomes, same direction. Then the federal guidance confirmed it. A single reflective layer facing an airspace can cut radiant heat gain by at least 90%. Not with refrigerant, not with a compressor, not with a fan, with a surface. That was the moment the number changed shape. It was no longer abstract. It was a stream, a downward stream from a hot roof into insulation, drywall, furniture, lungs, sleep, and every electric bill that arrives after sunset. I started sketching the path on a legal pad: roof deck, airspace, insulation top, ceiling gypsum, bedroom air, human skin. Once you draw it that way, the scam becomes visible. You are not paying only to cool rooms. You are paying to undo a preventable transfer that begins inches above your head. And the roof does not stop after noon. It keeps loading the house after the sun shifts west. It keeps feeding the attic long after the light gets softer. That stored heat keeps radiating downward while you are trying to sleep. That is why some houses feel hottest at 7:30 p.m. The sun is leaving. The roof is still working. Nobody told you. Not your builder, not your contractor, not the man who sold you a larger unit. And the most revealing part was this. The documents were not hidden because they were fringe. They came from Penn State, Oak Ridge, and the Department of Energy orbit. Mainstream institutions, mainstream measurements, mainstream physics. So why does the average homeowner still think summer heat enters a house only through air leaks and thin insulation? Why do people keep treating a roof like the problem starts after the heat is already inside? Because once you understand what a hot roof is actually doing, a great deal of modern spending stops looking necessary. It starts looking convenient. For someone else. That knowledge never disappeared. It was written out of the manual. It was waiting. Here's what the evidence shows, and here's why nobody was supposed to find it. Your roof can be turned from a radiator into a shield with a low-emittance surface that costs less than a dinner out, and the hidden number behind that claim is 0.05. That is the effective emittance range Oak Ridge modeled for a real radiant barrier, compared with 0.90 for the ordinary hot surfaces above your ceiling. And yes, this works even if your house was built 50 years ago. Stay with me. Because what I found in State College uses the same physics the Persians and Egyptians used to make brutal heat survivable long before a thermostat existed. The science is brutally simple. A hot roof does three things. It conducts heat through materials, it warms attic air by convection, and it radiates infrared energy downward onto everything below it. The part most people miss is radiation. The Building America Solution Center explains that a radiant barrier is a reflective aluminum surface placed next to an airspace so it can block radiant transfer between the hot underside of the roof deck and the cooler insulation below. Aluminum matters because it reflects long-wave infrared well and emits very little of its own heat. Penn State's Pennsylvania Housing Research Center ran the numbers using a 170-degree Fahrenheit summer roof and a 70-degree interior condition. Their slide deck put the summer radiant heat flux at 134 watts per square meter. In the winter comparison, it was 44. That means the summer radiant problem was 3 times larger. Oak Ridge National Laboratory also modeled attic systems with emissivity values dropping from 0.90 to as low as 0.05. Same roof, same sun, entirely different behavior. Think of it like a cast iron skillet. A hot skillet does not need to touch your hand to burn you. You feel it across the gap. A low-emittance barrier changes that exchange before the heat settles into the mass below. In field guidance, the Department of Energy says a radiant barrier can cut attic-to-house heat flow by about 40%, and a first foil layer can cut radiant gain by at least 90%. In performance terms, that is cooling load avoided with zero electrical input, versus a conventional air conditioner that still has to buy every unit of cooling with a compressor. That gap represents a massive market in equipment, service, and replacement every year. And that is why you have never heard of this. I went to Lancaster County, Pennsylvania in late August because paper alone was not enough. I wanted the sound test. I wanted to hear what cooling feels like when machinery is absent. I stood inside a farmhouse near Strasbourg in the heavy part of the afternoon. No condenser, no register hiss, no compressor cycling. Only floorboards, a distant horse, and the soft slap of a screen door. The upstairs was warmer than the cellar, of course it was, but it was not punishing. The windows were placed to move night air. Shade sat hard on the west side. Cooking heat stayed out in the summer kitchen. Reuben told me, very plainly, that his mother had no interest in heating the living rooms twice, once with the stove and again with the roof. That line stayed with me. He showed me the detached workspaces and the habit of keeping heat where it belonged. Outside the family rooms, outside the sleeping rooms, outside the afternoon stillness. He said the principle had been in the family for 4 generations, before Pennsylvania, before Ohio, before the move from the Palatinate and Swiss country. The Pennsylvania Historical and Museum Commission notes that summer kitchens kept oppressive cookstove heat out of the house, and that many detached kitchens in German Pennsylvania date from the 18th century through the early 20th. The method changed shape. The logic did not. What struck me most was the discipline of it. No one there talked about hacking comfort. They talked about placing heat where it does the least damage. They talked about porches, cellar time, window timing, and not inviting roof heat into the rooms where people rest. Lydia said the old families learned quickly that summer punishment comes in layers. Sun first, roof second, stove third. You remove each layer before it reaches the body. Then we attack symptoms with equipment. Take that logic backward, and the map gets older fast. Ancient Egyptians used the mulkuf, a wall opening facing prevailing winds, to pull air through dwellings built from mud, brick, and stone. The University of Arizona's 2024 review points to rooftop sleeping, courtyards, and wind capture as direct heat survival tools. In the Persian city of Yazd, wind catchers rose above the roofs and pushed air downward, sometimes across subterranean water, and the Dawlatabad Garden Tower still stands 33 meters high. Different land. Same answer. Keep solar punishment off the body. Move heat away before it settles. Build around the physics instead of buying your way out later. The Egyptians used wall openings and mass. The Persians used towers, shade, and pressure. They did not share a contractor. They shared reality. The Persians didn't read this in a textbook. They figured it out the way all real knowledge gets discovered, by paying attention to what the earth was already doing. Hot air rises, shade buys time, mass slows pain. A reflective or low-emitting surface changes the exchange before it becomes suffering. Once you see that pattern, the modern attic looks less like progress and more like amnesia. Every civilization that mastered extreme heat arrived at the same answer independently. The Amish never forgot. They carried it from the Palatinate to Pennsylvania 300 years ago and kept building it because it worked, and because they never needed anyone's permission to do what made sense. Now for the part that should make you angry. In 1945, Penn State building researcher Everett Schumann recommended a standardized way to express resistance to heat flow. It became the R-value system. Useful, yes, but once builders, lenders, and manufacturers had a single number to print on a package, mass insulation became easy to market and easy to finance. By the time Owens Corning was selling all-fiber fiberglass insulation into post-war subdivisions in the 1950s, the industry had a language that favored thick products you could stack, label, advertise, and mortgage. A radiant surface facing an air gap threatened that simplicity, and simplicity was worth real money. The mechanism was not a smoky back room. It was paperwork. The 1958 Federal Housing Administration Minimum Property Standards became, in HUD's own later words, a de facto building code, a largely prescriptive document. It specified allowable methods, materials, components, finishes, dimensions, heating and air conditioning practices for the houses that would receive mortgage backing. Once the manual became the textbook, anything that did not fit neatly into the approved language or the R-value habit started living at the margins. Not because it failed, because financed repetition was more profitable. Then came the allies. Consumer shelter magazines sold modern comfort. Better Homes and Gardens and similar titles were thick with ads for mechanical convenience and insulation products. The government side standardized the acceptable house through FHA-backed practice. The industry side sold the units, the bats, the ducts, the accessories, and the replacement cycle. Carrier and General Electric rode home cooling into the middle class. Owens Corning rode labeled insulation into the same rooms. Their financial interests did not need a secret meeting. They were aligned in public. An entire field of knowledge disappeared from architecture schools, building codes, and homeowner common sense. Not because it failed, because it wasn't profitable. And the continuation is still visible. During the 2022 and 2023 cycle that produced the 2024 International Energy Conservation Code, proposals to widen cool roof style protections into low-rise residential practice did not survive in any meaningful prescriptive way. A National Association of Home Builders page openly says the group was represented on both consensus committees to protect cost-effectiveness and builder flexibility. A 2024 National Association of State Energy Officials brief notes the finished 2024 ISE has no prescriptive or mandatory cool roof requirements for single-family homes. Open Secrets shows knob lobbying in the multi-million-dollar range and the Air Conditioning, Heating, and Refrigeration Institute above $1 million in 2021 alone. The motive is not mysterious. Every passive heat control measure that lowers cooling demand threatens equipment sales, add-ons, and future service work. The residential cooling and HVAC market in America is worth tens of billions of dollars a year. Every passive barrier installed is cooling that never gets sold twice. Now, if you already own a house, and you're thinking this only applies to people building from scratch, stay with me. Because this next part is specifically for you. You don't need to buy equipment, you need a weekend. Here is the simplest retrofit. Go into the attic, not the living room. Measure the underside of the roof on the side that takes the worst sun, usually west and south. If your rafters are 16 inches on center, great. If they are 24 inches on center, also fine. Buy perforated Astum C11313 radiant barrier foil in 48-inch wide rolls. A starter roll is often $22 to $31 for roughly 100 square feet. Add galvanized 3/8-inch staples, foil-faced butyl tape, polypropylene soffit baffles, and if needed, 1x2 kiln-dried pine battens. For a modest attic section, your material total lands around $96 to $184. Even a wider retrofit can stay under $500. You staple the foil across the bottom face of the rafters, not tight against the roof deck. That air gap is the whole game. Penn State says you need at least a 3/4-inch airspace for the surface to act as a radiant barrier. I like a 1.5-inch to 3.5-inch rafter cavity because it is common and forgiving. Leave a 2-inch opening at the soffit for intake air. Leave about a 1-inch space below the ridge so hot air can keep moving out. Overlap seams by 2 inches. Tape tears. Staple every 8 to 10 inches. If the attic hatch faces the hot side, line that too. If ducts sit in the attic, start above them first. The shiny face must look into open air. Dust matters. So does moisture. Perforated foil is safer in mixed climates because it does not trap vapor the way solid foil can. The air gap is not optional. Pressing foil against the roof deck causes direct conduction and kills the radiant effect. Do not bury it under loose fill insulation. Do not sandwich it flat under OSB. That is how people install a good material badly, then blame the material. If your attic is divided, do the west roof plane first. That is usually where late-day suffering comes from. If you have a knee wall room, staple foil on the hot roof slope above it and seal the hatch with foil face tape around the trim. If you have ductwork crossing the attic, keep at least 3 inches of clearance around hot flues and never block a bath fan exhaust. This is not delicate work. It is measured work. Cut once, keep the channels open, let the roof breathe, and do not overcomplicate it. 1 clean layer beats 2 sloppy layers. A single foil layer already delivers the real win. The Department of Energy guidance says the second layer adds little because the first one already knocks the radiant exchange down so hard. That matters. It means you are not building a spaceship, you are interrupting a heat pathway. On a 95-degree day, with a roof deck driving hard into late afternoon, this setup can cut the attic-to-house heat flow by about 40% and reduce radiant gain by at least 90% at the first reflective layer. In a house with a punishing upstairs bedroom, that often means the ceiling stops feeling like a warm plate above your head after sunset. The job takes 1 Saturday morning for a small attic zone and 2 weekends for most full retrofits. Maintenance is simple. Check it once a year. Clear soffit vents. Fix torn sections. Brush off heavy dust if it builds up. Your conventional central air system costs $7,000 to a very to $14,000 to install, $96 to $287 per month to run in hot weather, and lasts 12 to 18 years before it ends up in a landfill. This costs $96 to $184 for a starter retrofit. It lasts 20 to 30 years. Your choice. Everything I've covered across this channel, root cellar airflow, lime wash walls, summer kitchen habits, I've put it all in one place. Step by step, season by season, room by room, in the order the families actually use it. It's called Link is in the description. But stay here, because what Ruben showed me is the part nobody is talking about yet. If you're the kind of person who believes that real knowledge has been quietly pushed aside to protect someone else's profit, you already know what to do. Hit subscribe. Not for me, for what comes next. Because this is not a channel. This is a quiet movement of people who have decided they're done being sold what they already own. I want to hear from you. Drop your state, your hottest upstairs room, and your worst summer electric bill in the comments. I read every single one. And your answers decide what we cover next. Next week, I'm going to show you what a 1946 Penn State document reveals about keeping food cold and rooms dry with nothing but shade, moving air, and a buried line. And the report that proves university engineers understood the trick decades before the average homeowner ever heard about it. You're not going to want to miss that one.